All right, ITS148, January 15th, and this is the third day of class, and so we're into chapter 3, I believe, today. So let me share my screen. I'm going to do this one and this. All right, and I'm going to put this down there, and let me put this down and go here. All right, so today we are right here, January 15th, class number 3, chapter 3. So we're doing this right here. Oops. Does this work? This is what day we're on today. And so if we, let's see, let me see, I did, oops, I can't. I don't know how to do that. I've added some quizzes. I've added quiz 3 and 4. And, all right, I have some comments on that, but I'll wait till I get into the slides to talk about those. I did make a slight modification to this assignment. I simply, instead of saying go look in chapter 3 for the code, I just said complete exercise 2-1 and 3-1. And 3-1 is simply adding the code for 2-1. So I'm basically, the assignment's the same, it's just that I've phrased it more accurately. So if we go to the PowerPoint slides, I guess we're on chapter 3. So let me save these. And I'm gonna, well, I guess I can just open it up. All right, so of course we know all this stuff already, but here we're introducing, in this chapter, we're introducing, you know, coding. We've created the display. In chapter 2, as you remember, we've created this display for what invoice, calculating the invoice or something. And in this chapter, we're going to insert some code to make it work. And the point of this chapter is to understand all of the extra features and support that Visual Studio itself provides for you when you're writing your code. So let's start by going through the slides, and then after that we can go over and add code and look at the rest of the assignment. All right, so in this chapter, we're gonna, given the code for a sample application, use the skills presented in this chapter to add code to the application. Okay, so you know, we aren't yet developing our own code. We aren't yet in this book. You've done it already in 128, but in this book we're just at the stage where they give us the code and we figure out exactly where it goes and everything, so we get used to using Visual Studio to add to write code. And this book is a lot more comprehensive in covering all of the features that Visual Studio provides for you, whereas, you know, in 128 we didn't really 128 was not really a comprehensive look at Visual Studio or a comprehensive look at C#, but this book is a lot, I would call this book much more comprehensive. So we'll learn, we will go over again things like using indentation for lines and, using indentation for lines, blank lines, and adding blank lines so the code is easier to read. Using comments, you should probably put some comments in your code. It used to be a lot more important in the old days because there were limits to the size, to the length of to the number of characters the variables could have, and so on. And in the old days, there was no reason to indent. We never indented. There was not concepts of the concept of a block of code. Blocks of code within a program. There was not really that concept. So comments were very important. Also, with lower level languages like assembly language programming, comments are very important, especially assembly language program, because the program itself is a bunch of 3 or 4 or 5 character mnemonics, as they are. They're just abbreviations for something, like LODX means load a number from the memory to a register X, load X, LODX. It doesn't really make a lot of sense at all. So for lower level languages, you put a comment on every single line. Every single program statement has a comment after that. In C# and in other higher level languages, it's not so necessary, because we can name our variables exactly what they do, and the indentation is similar to the same visual hints and clues that an actual flowchart gives you. Nonetheless, we should still put some comments on the code. And then there's some help features that we have in that Visual Studio provides you to help you develop the application. We're gonna in the context of object-oriented programming, we're gonna understand specifically what class, object, instantiation, instance, property, method, event, and member, what all those mean specifically in the context of object-oriented programming, and especially C#. You should be able to describe how an application responds to events. We have these event handlers. You'll learn what snippets are. The Visual Studio provides a lot of coding hints and little starting blocks. Like if you want to put an if statement, it'll put in it'll insert the template of an if statement, and then you just have to fill in the test expression, and then 2 blank blocks of code or 2 blank blocks are provided for you, and just insert code in the middle. You need to refactoring is things like changing the name of a variable, and it's also later on, as I think we learned in 128, refactoring is also the process of taking a block of code and turning that block into its own method and annotations and so on. We should already understand the difference between a syntax error and a runtime error. Syntax errors, of course, are found by the compiler, and Visual Studio can tell you as you're typing code whether or not you have just typed in a syntax, what you just typed has a syntax error, because it'll put a little red squiggly line below it and so on. Runtime errors, you wouldn't get a runtime error until all the syntax errors are out of your code and you're actually executing the program. So you're executing along, and then all of a sudden the program stops, or it goes bing, or there's what's called an exception, and those types of errors are only caught while the program is running. So that's the difference between runtime and syntax errors. Distinguish between testing and debugging. It's nuances there. Explain how a data tip can help debug a runtime error. So we're going to we're going to return to this starting of a program that we created last time. Is this invoice total, where you input a subtotal, and this discount % is fixed in there, and then it computes a discount amount. So the program writes that number there, this times this, and then the program also will add up to 22.5 plus 225, no, subtract it, and then get this number when you click the calculate button. First of all, class and object concepts. An object is a self-contained unit like a form or a control that combines code and data. A class is the code that defines the characteristics of an object. You can think of a class as a template for an object. An object is an instance of a class. The process of creating an object from a class is called instantiation. So you have this class, which is just a definition, which is just a program definition, and it sits there. It sits there while your program is running. It's part of your program, and then in your program, you can create an actual instance of that class. Now, say for example, a class has a couple of properties in it. It's got some methods. Properties, for example, take up memory space. If a property can store, you know, a person's age, for example, there's an integer or whatever it is, a decimal value or a double value or something that can store a person's age. It's a variable of a particular type that's included inside of a class definition. Just defining the class does not actually allocate the space. It is creating an object of the class, or creating an instance of the class, which actually allocates the memory. Now with a class, you can create multiple instances. Let's say you have a class that represents a person, and your program deals with 3 persons. So you might create 3 instances of the same class. Each class represents a different, no, each object represents a different person, and each object has, for example, an age property. But for each of the objects, the value of the age property would probably be different because it's representing different people. So a class is simply the definition. It's like a blueprint. It's like a blueprint of a house. You have the blueprints of a house. It's not a house. It's a template for a house. You can create an instance of a house, and you can create multiple instances of this of a house that's defined by a single set of blueprints. I've used the example that in my neighborhood, there's my house, which was built from a set of blueprints, I presume. But if you go down the block and turn right and go down 2 houses, there's another house there that's just like my house, probably created with the same blueprint. You know, no doubt the same set of blueprints, but it's a different instance. It's a different object. You know, the carpet in the living room. Well, actually, we don't have carpet in our living room, but the floors are different. You know, and so on. More than one object instance can be created from a single class. So that's an example I just gave. Inside of a class, or when we're defining a class, we've got properties, we've got methods, and we've got these event concepts. Property defines the characteristics of an object and the data associated with the object. So that'd be like age or square feet or number of bedrooms and so on. Methods are operations that an object can perform. So they're small little programs, as you know. They're little routines or whatever you want to call them. They're called methods. And methods are defined within a class. Their methods are of a class, and methods only operate on the properties that are defined inside the class. when you are creating when you're creating several objects of the same class, and so you have, let's say, again, you have a class which represents a person, and you create 3 instances of that person, so 3 objects, 3 separate objects. The properties actually do take up memory space. Methods, however, are probably not. There's probably not a separate method that's allocated. The code for the method is probably not allocated for each object because it doesn't need to be. But still, the methods are associated and operate only on the properties of the object that's associated with the methods. Events are signals sent out by an object to an application telling it that something has happened or that has to be responded to. And so if you double click or if you click on a button of an object, then that's an event, and that signals the object to it probably invokes a method a method within that object, and that executes. Properties, methods, and these events can be referred to as members of an object. So, we have properties, methods, and so on. Those collectively together are called members. If you instantiate 2 or more instances of the same class, all of the objects have the same properties, methods, and events. However, the values assigned to those properties can vary from one instance to another. So it's the properties, it's the values that are assigned to the properties that can vary from one instance to another. All right. So when you use the form designer, Visual Studio automatically generates a C# code that creates a new class based on the form class. Then when you run the object, the form object is instantiated from the new class. So you create a form using the form designer, and you create some code in there. You put some code in there and everything. That's actually a class that you're defining, and you can create more than one instance of that form. We usually don't, but you can. When you add a control to a form, Visual Studio automatically generates a C# code in the class for the form that instantiates the control object from the appropriate class and sets the control default values. So in our case, most of the time we are, we have this form, this startup form, and we've defined the startup form with a bunch of code and property definitions and everything. And then when we execute, it's going to create, it's going to create an instance of the form that's defined as the startup form, and that's it. There could be other forms defined. There could be the same form class defined, but it's only one object of that startup form that's instantiated or created. So that's one object. Now the code, the methods of that startup object, the startup form, can create instances of other forms defined, and so those, of course, aren't created until some program wants to create an instance of it. Anyway, so Visual Studio helps support all that, and you don't really. It's almost like you don't really have to understand it. You can just use it. I know that's not comfortable for some of you, but it's the problem with programming these days is you have to take a lot more on faith. Back in the old days, it's just like you could you write this code, and there's no concept of object and class, or it's just you write the code, you might define some variables, or and so on. You define there's no concept of a template and an actual instance, there's none of that. So the only thing you had to really visualize, take on faith, is when you define a variable, that underneath there's some memory that's allocated, in some place, and then you have a program, and that accesses the memory and does something to it, reads it out, stores it back in, and that's really all you had to conceptualize in your mind. Today, there's a whole lot more, and takes a different kind of, a certain level of faith that we didn't need to rely on back in the old days, but that's kind of how it is now. But you sort of get used to it after a while. Here's a member list in the code editor window. Not sure what this is supposed to depict here. Member list of the code. I'm not sure what that's supposed to depict. This is an example of some code, or this here is a method here. This thing is a method that was created by double-clicking on this BT on a button, on the calculate button. The name of the button is, the name of the control is called BTN calculate, and when you double-click on that, it automatically creates code for the button click event, single click event. And so this private void BTN calculate underscore click object sender event args e begin curly brace, end curly brace, that's created, and then you just go inside these curly braces here and you start writing your code. This looks like more of an example of IntelliSense, where you type convert to decimal txt subtotal, and txt subtotal is the name of a text box that's on the form, and so once you type txt, it's probably going to IntelliSense list of all of the objects that start with txt, and so in this case it's text boxes, but using the convention in this book. And then when you get to you put the period, and then after that, as you start typing a list of all of the possible properties or methods, members that are valid associated with this object will appear. The list is there, and you're able to easily figure out which one it is, usually. The syntax for referring to a member of a class or an object is, as I just said, you have the class name, period, and then the member name, or the object name, period, and the member name. So for example, statements that refer to properties, txt total is the name of the object, and this text is a property of this txt total class, and it's the text property, and so you're able to assign a text value to that. This is a property that accepts just true or false, and so you're able to specify that this particular object is read-only. And so by read-only, it means you can't write. And so these objects here, this one, and this one, are read-only because, as you can see, it doesn't have a white background. These values are written there by the program, or in the case of 10%, that could be defined right in the program when you're defining this particular text box. And so these three here are read-only, while this one is both read and write. So, and then this also is an example of a Boolean property. A Boolean property is a can only take on true or false. So, Boolean is true or false. So this is defined. This is declaring or assigning the value true to the read-only property, which makes it read-only. And then these are some methods. Okay, these over here were properties. These are properties, so they take on values. These are methods, and methods, when you address methods, you're executing something. So because this is a method, focus is a method. It's a built-in method that comes, that all text boxes have associated with them. And this particular method, this focus method, will make it so the cursor or the blinking cursor, where if the user starts typing, the focus of that typing will be this text box. So when this when txt monthly investment dot focus, paren end parentheses, end parentheses, when this thing is encountered in the program, then this method, which is associated with this method, which is a member of this object, it's a method, so it executes, and then that makes it so the user doesn't have to move the mouse and click on this text box. The focus is already there, so the user can just start typing. This here is the close method. This word "this" is a keyword which refers to the current instance of the class. So this refers to the object that executes it. You know all this already. I'm just explaining it, and in the terminology that's used in this textbook. And for you folks in this class studying this chapter, it's kind of more about refreshing our memories on the actual terminology of all these things, because you certainly have already written code that's got that uses the close method. If this is a form, and if it's some form and this is executed, then once it's executed, the form will disappear. And if it's the main form, then the program itself will be done executing. This is code that refers to the click event. Refers to the click event of the button named BTN exit. So this is something that you would see in the property. I guess it's a property that contains the name of a method that is executed when the exit button is clicked. How to enter member names, and to display a list of the available members for a class or an object, type the class or the object name followed by a period. The period is called the dot operator. It's kind of an operator. And then type one or two more letters of the member name, and the code editor will select the first entry from the list that matches those letters. You'll see that we've been talking about this IntelliSense. You start typing some letters, and then this list comes up, and you can select from there. If you type some letters and the list comes up and you don't see what you want, then something's wrong. You're not typing the right first two letters, or maybe you think you're referring to an object, but you're really referring to some other object or something like that. If a list isn't displayed, select Text Tools option to display the options dialog box. Then expand the text editor group. Okay, so this I guess if your IntelliSense is turned off, then this helps you turn it back on again. So an event is when, something happens on the screen, anything that happens on the screen. You can roll your mouse over a text box, that's an event. You can press down on a key, that's an event. You can release a key, that's a separate event. And you can associate methods with all those events. Most objects have lots of events that can be defined, or you can define methods associated with those events, but we don't do it. Like a button's got a lot of events. You can roll your mouse over the button if you want. If you want to make it so instead of having to click the calculate button, you just roll your mouse over the calculate button and then it works. You can do that too. You just have to associate the event, the code for the event, or the method for the event that you would associate with clicking. You can simply just in Visual Studio, you can go to the methods section and select and find the event for rolling your mouse over it, and then select the event handler, which maybe you've defined for calculate, and you should see that work. By the way, am I recording? Yes, I am. So when you write this, writing the application determines which method to execute. You don't need to, this is not something that you need to do. This code you don't need to write. This code is taken care of in Visual Studio. But it's called, this book also covers some more of the internal, the internal things that go on with Visual Studio. When you double click on this, on the exit button, for example, this code is automatically entered in, okay? And it's not something you even see. What you see is the place where you enter in the code for this, for the btn exit _ click. That's this here. And so, you double click on this exit, and then this private void, this thing pops up without this thing in the middle, this dot close, and you add this dot close here. You add this code, and then that's all you have to do. This is automatically inserted someplace. I think it's in the program.cs file. We can look and find that. And then, so this is all you need to do for this form, or if you click on the exit, it'll close out the form. So these are some common control events. Click, of course, there's a double click event. If you want to make it so the user's got a double click instead of just single click. There's enter, if the focus is moved to the control, and leave, the focus is, these are events. You can use the dot focus method to bring the focus, the cursor or whatever, to the object. That's a method which makes the focus be the object. This enter event is where if the user clicks on the text box, for example, then this enter event has occurred. So it's kind of the opposite, where you if you do dot focus, the cursor moves to the text box, but if the user clicks on the text box, to manually bring the focus to the text box, then you have triggered this enter event. If you then decide to click on some other text box, then this leave event has been triggered. So if you have a method, if you define a method that executes when the leave event occurs, then something will happen when you click someplace else. Common form events are load, a load event handler, and we use that a lot. Closing a form, that's an actual event. You can click on a button to cause the form to close, or and however the form closes, when it is closing, just before it disappears, into nothing, this closing event is triggered. So closing means it's just starting to close. Closed means it is completely closed. So if you have a subform and you close the subform, then at the moment it's closed, the moment it's done closing, it's done. Then it's closed. Then this closed event is triggered. So how an application responds to events. Windows form applications work by responding to events that occur in objects. To indicate how an application should respond to an event, you code an event handler. Event handler, that's a quiz question, which is a special type of method that handles the event. So, methods are methods, but those methods which are specifically designed to happen or to execute when a particular event occurs are called event handlers. To connect the event handler to the event, Visual Studio automatically generates a statement that wires the event to the event handler, and that's what we were looking at before. This is wiring the event to the event handler. Now, I'm quite sure, because there's no form, there's no definer form, there's no designer form facility in Visual Studio for the Mac. Since you don't have something that looks like this when you're writing your code on the Mac, then there's no thing that you can like double click and then this pops up. This is when we're talking about so if you're designing a program using Visual Studio on a Mac and you don't have this form designer facility, then you actually have to do the wiring yourself. To indicate how to connect an event handler to event, Visual Studio on Windows, Visual Studio on Windows automatically generates a statement that wires the event to the event handler. This is known as event wiring. An event can be an action that's initiated by the user, like a click event, or it can be an action that's initiated by the program code itself, like a closed event. So you might want something where, however this subform closes, you want to make sure that before that form actually closes, you've copied over some data, or you've passed some data back to the, you've passed some final data back to the calling program or something. And so that would be an event that's initiated by something else that happened in the program. So events can be initiated by a user, some sort of user event, or it can be also initiated by something that happens in the program. Events are how things like there can be outside external events that occur too, like let's see, when you are, let's say you're writing a program, let's say you're writing the program that prints to a new kind of a printer or something. Let's say you get some kind of new kind of printer to printer or something. I'm just trying to think of an example of where there can be some external hardware event that occurs, and that triggers code to run inside the code that you've written. If you're interfacing to a printer, for example, maybe not the new printers, but the old printers, the old days, the way they would work was, you know, your program sends a character to the printer to print, and then goes off and does something else. And then after the printer is done printing that character, it sends a signal back that says, okay, I'm done printing that character, you can send me another character, and then the program, then whatever your program is doing, you know, recognizes that this event was triggered, and the event is the printer is asking for another character to print, and then so you go execute your event handler, and then when you're done sending the character to the printer, you return back to what you were doing before. It might not be a character these days. It may be a whole line, or it could be a whole buffer full of data or something. But when the program is interacting with peripheral devices, those aren't really events that are triggered by a program, some event caused by some program executing. They aren't events that are triggered by the human, but they're events triggered by some other external thing. So not a problem. So this is the method that handles the click event of the calculate button. So after you've named your calculate button BTN calculate, then it's time to write the code, you know, and it's time to write the code for what you want the button to do. You double click on that calculate button, and this code right here, you end up right here, and the cursor is right there, and you can just start typing the code for what you want it to do. We've never talked about these what these parameters mean, this object sender event args e. We're going to finally get a chance to talk about those, but those are just parameters, arguments that come from the button, and what this is saying is what is passed is two variables. One is called sender and one is called E, and sender is an object type. An object is the most general type of variable, as you can say, there is. It's an integer, you know, there's double, there's different types, and object is the most general type, because object can be anything, and you know, you just have to look and see what it is. And these event args are arguments from the event, or arguments from the object related to the event that caused this method to be invoked. And so there can be various parameters that come in from that, and your object, like in this case the calculate button, can also pass parameters. So anyway, we'll see. We'll learn and utilize that more in this semester. What else was I going to say about this? You notice here that it also uses this convention for forms. This particular program that we're talking about here only has one form, and that's it. But still, he's consistent, and he uses this naming convention So when you have a program that's got a bunch of forms and you can't think of what the name of the form is that you want to invoke or whatever, you can just type FRM and then a list of the forms that you've created come up. So in the form, so to write a click event, the form designer, you double click on the control, this opens the code editor, generates a declaration for the method that handles the event and places the cursor within the declaration. So, double click on it and places the cursor right there. And so then you go ahead and type in the code between the opening curly brace and the ending curly brace. And when you're finished writing the code, you can return to the form designer, by clicking on its tab. Handling a load event, you recall that's an event which is triggered when the program loads or when the form loads. So we've dealt with, programs that only have one form, and so for the single form programs, the load event is basically the first code the first user defined code that's executed when a program starts. So you recall we had load events where I think we had a program that kept track of your friends or whatever, and we might have created a load event where once you start up the program and the form gets displayed, right when the form is completely displayed, then the load event handler executes, and that load event handler can go out and read the file or read your names file. So when the form actually appears and the user sees it, the list box or whatever that has the list of all your friends is already populated with all your friends. And to define a load handler, you double click on some space that doesn't have an object, and that brings up the this part here. This part here to enter in the code that you want to execute when the form loads. These are snippets, code snippets, and it's it's regular IntelliSense stuff. You start typing, and it displays up things that you may it's you type an I for if, and then this list comes up of all of the things that you could be about to type that would make sense. And so for this case, this would come up, and then if you actually select that, then what appears, does it show what appears? Well, anyway, what appears is a nice template for an if, and it ends up looking, okay, this is, I guess this isn't snippets yet. It is snippets. If code snippet for a statement, notice tab twice to insert, okay, so you tab twice to insert the if. Here we're starting to type what is in the condition, the conditional expression, and so this is typed in, and then this appears, and you can just type the code in there. Event handlers for the invoice form. Okay, so so here, starting on page 19, slide 19, we are showing you the code here, which is the event handler for the clicking the button. And this is code that you're going to enter in for your assignment, for the assignment that's assigned. This is the exercise 3-1 code that the exercise asks you to enter in. So this, of course, is in the textbook, But this basically is, do we go over this code here? What is this? So if we go over this code, you should recognize this stuff. This part here, the yellow part has already that appears when you double click on the button, and then you enter in this code here, starting this, and then this finishes it. Oops. And so this code we can quickly briefly. This defines a decimal variable called subtotal, and then this thing here, this is the subtotal text box, and this is a method which converts whatever is in here, it's text, but this should be convertible to a decimal number. So it's just going to be some digits, possibly followed by a decimal point, and then some more digits. And this converts it to an actual decimal number format. You know, this here is just a string of characters. Once it's converted to a decimal number, then it's an actual number that's represented some way inside the computer, and it's a decimal representation. So that means it's what it's 128 bytes or something. It's the decimal point is someplace. Anyway, so this is converted to this decimal number, and then it's stored. The value is stored into this decimal number. And then this defines another decimal number called the discount percent, and it's set equal to 0. And this M, it indicates that it's a decimal constant. And I think M is short for money, because decimal types are the types that you use when you're dealing with money. Very accurate, you know, no rounding problems or anything. If you know, and it has to do with if you're dealing with trillions of dollars and interest rates that have several decimal points, and you do a bunch of calculations, and in the end you want the numbers all to come out, you know, right. You don't want to have any rounding errors, and so you use decimal numbers. And then so this subtotal is a particular value, and this is an if then else block here, and all this does is if the subtotal is greater than 500, it sets the discount percent equal to 20%. If the subtotal is between 250 and 500, then it sets the discount percent equal to 15%. And if the subtotal is greater than 100 and less than 250, then it sets the discount percent equal to 1%. If the subtotal is less, if it's not this, and it's not this, and it's not this, then it stays whatever this is. See, first it sets it to this, 0, so the discount percent is 0. So if you just buy something for $1, you're not going to get any discount. But if you buy something for $600, then you're going to get this discount. If you buy something for $300, it's going to be this discount. If you buy something for $200, since it's between here, it's going to be this discount percent. And then this takes the subtotal, which was in the text box, multiplies it by the discount percent. So that gives you the amount that you're going to discount, the discount amount, and then the total, invoice total, is going to be the subtotal, which is this thing, minus the discount amount. And that's the calculation that your little window should do. And then after that, we want to display all this stuff out. You know, so this thing is going to take the discount percent and it's going to convert it. It's going to convert it to a string. It's got to convert it to a string before it writes it to a text box, because you can only write strings. You can only write text to a text box. You can't write a decimal number to a text box. You have to convert the decimal number into a character string that represents those digits that the text box or that this number is in. This is the format, and there's a bunch of different formats. I'm not sure what the P stands for. This here is this is for currency. This says take this discount amount value. Oh, P is percentage. This is percentage, probably with 1 decimal point afterwards. So if what kind of discounts we have? Oh yeah, we got a 0.2, 0.15, and 0.1. P1. And C is currency. So so that ensures that the formats look like this. Oh, it's P with, oh, I see. Oh, it's percent. Yeah, that's right. Okay, so it's basically, it's 10%. So see, the number is 175. If it's 175, then that means it's in between here. It's in between here, 175. And so the discount percent is 0.1, and that is 10%. So this is, this makes it, displays 10.0%. This is going to display currency, which is going to look like this. It's the value is what? No, it's discount amount. The value is 17.5. That's the value it's going to display. That's the decimal number that was the result of the calculation. And but we ask that it be displayed in currency format. Currency format. That's the C. So what's currency format? Currency format means have it be a number with two decimal digits, and throw a $ in front. And also, if the number is bigger than 1,000, it throws commas in there too. That's a quiz question. Where are we? All right. So so this the last thing it does is it displays out that total. And then, no, that's the second to last thing it does. And then the last thing it does is it brings the focus back to the subtotal. So when this thing is all done executing, okay, when the calculations are all done and the results are displayed out and the form is sitting there, this last thing that executes focus on subtotal, that's going to make it so when the calculations are all done, the focus is going to be back on this thing up here, this subtotal thing here. And so it's right there ready for the user to type in a new subtotal, you know, to do another calculation. Presumably this is, you know, this is at a store or something, and you know, people buy stuff and you got to quickly calculate the percent, whatever. All right, where are we? Okay. So common control events. This textbook is nice because it has these blue boxes, or these boxes these would be on the right page, you know, when you're paging through the book. The left side, the left page is always like nice text, you know, text that explains the concept that this double page is supposed to display. On the right side, it sort of summarizes and gives bullets and has these nice blue boxes and so on. And so this lists some common control events: the click event, the double click, the enter, the leave. These are common form events, which is load form, closing the form, and close the form. Did I go over these already? Did I skip something? I think I went, did I go? I think I went over those already. Anyway, sorry for repeating myself. All right, coding rules. Use spaces to separate words in each statement. Use spaces to separate the words in each statement. That makes sense. Use exact capitalization for all keywords, class names, object names, and variable names. Okay, so these are all just, these two things are conventions. Use exact capitalization for keywords, class names, object names, variable names, usually. End each statement with a semicolon. That's, you have to do that. Each block of code must be enclosed in braces. You have to do that too. That includes the block of code that defines the body of the method. You know, so when you're defining a method, you notice it's got these braces there. So these first two things are conventions. The last two things are things you have to do, otherwise your program will not compile. You'll have a syntax error. So syntax errors, you know, syntax errors, you spell a variable wrong, you spell a variable wrong. In C#, all variables must be declared before you use them. And that's good, because if you're typing in your program and you accidentally spell a variable wrong, it's not going to let, it's a syntax error, and you have to fix it. In other languages, which are not in other languages like Python, you do not need to declare variables before you use them. It's if you use a variable without declaring, okay, you can declare variables before you use them, but you don't have to. So if you accidentally misspell a variable and it's on the left side of an assignment statement, it doesn't think you're misspelling a variable that's defined earlier. It thinks you're creating a new variable. So if you're keeping track of the discount percent and you want to assign the discount percent something, and you accidentally spell discount wrong, and it's not C#, it's in that language like Python, then it's just going to think you're declaring a new variable. Well, that can be a problem because your program doesn't work, and you insist that you've coded it correctly, and really what it is you've accidentally defined, or you've accidentally spelled something wrong, and it thinks you're declaring a whole new variable when really you mean a variable that you've already defined. In C# you can't do that, and it's important that these strongly typed, statically typed languages that we use for writing production code, if you're a member of a team, a big team, and you're writing production code, you have to have all these checks and balances, so to ensure that the system ensures that you know what you're doing. And so, and that's why Visual Studio can actually tell you if you're doing something wrong. You know, if here it says, here you're writing some code and you're and you type txt%.txt equals something, and there's not an object named txt amount. You think you're referring to a text box that stores that you think you are referring to a text box named txt amount. The system says, wait, there's nothing named txt amount, so then it displays up this error. Where does it display errors? Two places. It displays an error right here in the code editor box by these red squiggly lines, and down in this error list thing here, it also says specifically what the error is. The name txt% does not exist in the invoice total current context. It tells you where exactly the error is. So sometimes these little red squiggly lines are slow to appear, and you know, you're writing code real fast, and you click run, you click start up here and execute, and then as it's getting ready to execute, it goes and checks all these things, And if it finds something like this, it's, oh, we're not ready to execute yet. We still have some syntax errors. And then this thing displays up, and then by that time, the red squiggly lines will show up, and then it's pretty easy to know what to do to fix it. Here it actually will suggest some fixes. And let's see, txt amount, txt percent. Do we have a clue as to txt subtotal? Yes, the names are different. I think we named them discount percent or something, and we named them subtotal, not what you see here. A method written in a readable style. Okay, so you have all this nice indenting. You've named your variables. This form of naming variables, it's called this here, where we capitalize the beginning of every word except for the first word. Okay, those are called, this is called, the book calls this camelback. Camelback notation. In the old days, we used to call it bumpy caps. And then another convention is this other, it's called Pascal notation, where you actually capitalize the first letter also. So this is very readable. You know, it might not look that readable now. No, this is 148. So this should be very readable for you. This is a continuation of it. And this is less readable. Same thing. The compiler doesn't care. The syntax checker doesn't care if you write it this way or this way, because what the compiler is looking for, or what Visual Studio is looking for, is things like, okay, let me open this up here. Can I do this? Okay. Okay, we have private void calculate beginning and end. Okay, so this lines up with this. Okay, so really what you should do is you should put like this over here, and you should indent all these things. This should be indented, 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 and so on. This should be down there. Let's just do this. Indented, 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 indented. What time is it? 3:05. This class goes till. What time does this class go till? 3 o'clock? Oh shit, it's over, isn't it? All right. So anyway, I get up here and I start talking. So this is only slide 43. This chapter is this is the only day we're covering this chapter. Okay, well, you know, I spent a lot of time on this. This is all in the chapter. Oh, okay. So let me just say, so note that it doesn't matter that code can be written like this, or it can be written all nice so it's readable. In the quiz, there's a bunch of questions where, you know, it's like 6 assignment statements, and they're all in a row because it's hard to format them when you're entering in the quizzes. And so there's semicolons, there are assignment statements, semicolons. So that kind of brings home this idea where, you know, the code written like this is only for the human. It's only for you when you're writing your code. This is perfectly fine for the compiler. Got a bunch of recommendations here. So this is all pretty much convention stuff, and it's using Visual Studio. And we will be using all of this stuff when we are writing code throughout this semester. So you're going to see all this again. Here we talk a little bit about debugging, and we'll actually cover that in detail later on. So anyway, thanks for coming today, and I will. I'll see you on Thursday. Thanks for watching.